In this lesson, we are going to be looking at the surface area of a prism. And while if you notice in your textbook, when they do a surface area, they generally unfold it and picture this as a net and find the area of all the surfaces. I'm not going to do that. I'm just going to view surface area as a surface area of a three-dimensional shape and leave it in its form, as I just find that a little bit easier for my brain. But if you have a different way of picturing things, absolutely you can draw the net and figure out the surface area that way of these particular things. But the key idea here is that surface area, which I'll refer to as SA, is the sum, which means you're going to add the sum of the areas of all the faces of a 3D object. So in other words, the surface area, you're going to be finding out the area of every surface on the particular shape and adding them up, because that's the total surface area, or the area of all the surfaces. So we're going to look at two shapes today. We're going to look at rectangular prisms and triangular prisms. Rectangular prisms always follow the same pattern, and you'll notice that as we get into this single example. A rectangular, sorry, that's spelled wrong here. A rectangular prism has 6 faces. If you pulled out a box, you'd notice that it has 6 flat sides. Okay, and every flat side is a rectangular face. So we're going to look at an example, because basically mathematics is the ability to actually do the math and understand a problem that has numbers with it. So this blue example here, we're going to calculate the surface area of this particular box here. So the 6 surfaces that I'm referring to are, for example, the top, bottom, left, right, front, and back. So those are all the surfaces. Now the nice thing about rectangular prisms is that they all come in pairs. Each pair is actually, or each surface has another surface that's exactly the same. So if I look at this bottom here, that bottom has dimensions of 4 times 3. So the area is going to be 12, and we'll write down the mathematics here in just a little bit. But what you'll notice is the top is actually the exact same dimension. So there's going to be 2 of those. So when I write about it, I'm going to write about it this way. And this is the part that you're going to want to write down. But yeah, if we want to find out the surface area, or the area of the top and bottom, they're each going to be 4 times 3. And area, again, is units squared. So they are 12 centimeters squared each. And what I can do then, if I want the top and the bottom, is times it by 2. So that's 24 centimeters squared. So that's the area of the top and the bottom. So we have now found out the area of 2 out of the 6 faces. Now in blue, what I'm going to highlight here is the right side. This right side of the shape, if you look at the measurements or the dimensions on it, the area of that side, if you were to picture that as a rectangle, is 6 times 3. And what other side has the other face has the exact same area is the left side. Okay, so each of them has an area of 6 times 3. So let me show the work for that. And you want to keep yourself quite organized as you're going through problems like this, because there's a lot of work to do. So the left and right are 3 times 6, which is 18 centimeters squared, and that's each. And since there's 2 of them, I can take that 18, multiply it by 2, and that's 36 centimeters squared for an area of the left and right. Now, the last surfaces that I haven't calculated yet are the front and the back, which I'll look at here in green. Now, in some cases, it's a little bit harder to figure out the area of a particular surface, because the measurements are a little bit further away. So if you look at this particular surface, or face, the front, it's 4 times, and the height is actually 6. So even though the 6 isn't directly beside that, that is the height of this particular face here. So that front, again, the area of the front is going to be 6 times 4, and another surface that has the exact same area is the back. Okay, so let me just write about that work. So that's going to be front and back, and they are 4 times 6 each, which is 24 centimeters squared each. And 24 times 2 is equivalent to 48 centimeters squared. So the final thing, and the big key idea of surface area, is it's the area of all the surfaces. So now that we've calculated the area of all of the surfaces, if we add them up, we'll have the total surface area. So here's the area of the top and bottom, left and right, front and back. So if we add those numbers up, we will have the total surface area. So if I add those up, 24 36 and 48. The total surface area is 108 centimeters squared. So the nice thing about rectangular prisms is they always come in pairs. The only exception would be if one of the faces was missing. So if you had a fish tank that did not have a top, because it was open, then you wouldn't have to calculate the area of that face. But if all 6 faces are there, the pattern remains consistent. So the next shape that we're going to look at, and we're going to actually do 2 of these, so this lesson's a little bit longer than typical, is a triangular prism. Triangular prisms are a little bit tricky because they're all unique in a lot of cases, so you're going to want to be careful about looking at triangular prisms. But the one thing that all triangular prisms do have in common is that a triangular prism has 5 faces. You can look at them, and there's 5 flat faces on a triangular prism. 2 of them are triangles, and 3 of them are rectangles. So let's investigate, and again, you might want to take some time sketching out this diagram, as we're going to be looking at surface area of this triangular prism. Let's investigate this first problem together. So, the first 2 faces that are identical all the time are the triangles, and there's something unique about triangles that you need to remember. So this triangle here and this triangle here are exactly the same, and I'll call them the front and the back in this case. Now what we need to remember about triangles is the area of a triangle is base times height divided by 2. So this triangle, what you do with triangles is you look for the right angle, because the right angle are where the base and the height meet each other. So the base of this triangle is 18 and the height is 12. Okay? So let's organize our thoughts here. So the front and back, which again are triangles, and remember triangles have a slightly different formula for area, base times height divided by 2. So each one, the base is 18 of each one, the height is 12, and then we need to divide that by 2 to figure out the area of just one of the surfaces. So 18 times 12 divided by 2 is equivalent to 108 centimeters squared, and that's each. So if we would like to figure out both of them at the same time, we could times that by 2, and that's 216 centimeters squared. Now the remaining surfaces, I'm just going to actually erase some of this stuff as this gets pretty detailed here. The remaining surfaces are all rectangles, but the interesting thing about this is that not all the rectangles are always the exact same. So if you look at these rectangles here, what you'll notice is there's actually 2 of them that have the exact same dimensions because of these lines here, which mean that they're equal to each other. So this rectangle here that's facing us has dimensions of 15 times 24. And another rectangle that has the exact same dimensions is this rectangle that's kind of on the back left side, you can see there. So that's also a 15 by 24. But those are rectangles, so we don't need to divide the area by 2. So on each one, and let me call those in this case the left and right, the left and right are each 15 times 24. 15 times 24 is 360. That's each. So if we times that by 2, we're going to have 720 centimeters squared. And the last surface that we haven't yet found out the area for is the bottom. And the thing to be careful of is the bottom doesn't have a pair, okay? Which is absolutely fine. So we've calculated the front and the back, the left and the right, and the last surface that we don't have the area for yet is the bottom. And the bottom here, if you look at it carefully, is a rectangle, and the measurements to calculate that area are 18 times 24, and there aren't 2 of them. So this is just a single bottom, and the bottom is 18 times 24. And 18 times 24 is 432 centimeters squared. So now we have calculated, and let me circle them in black, we've calculated the front and back triangles, the left and right rectangles, and the bottom rectangle, and if we add all of those up, because surface area is the sum of all of the area of all the faces, we get 1,368 centimeters squared. That is the total surface area of this particular prism. Okay, we're going to do one more shape because triangular prisms tend to be tricky. So if we look at this triangular prism, it's been tilted upwards, and that can make some people a little bit confused. So let's go ahead and look at it. I'm going to do this one a little bit more quickly. You might want to pause the video throughout. The first thing I notice is that these two triangles again are the same. But the base and height, so remember for triangles, base times height is and divide by 2. The base and height meet at the right angle. So the base and height are 4 and 3. Okay? So to figure out the area of each triangle, so I'm going to call this, in this case, the top and bottom. And it doesn't matter what you name them as long as you're understanding that you need to find out the area of every surface. But each one is going to be 4 times 3 divided by 2, and that's equivalent to 6 centimeters squared each. So if I do 6 times 2, I have 12 centimeters squared. Okay? Next. The next thing you'll notice is that the 3 rectangles are actually all unique from each other. So I can do these all in parts. It doesn't matter which part you do when. If I look at this back rectangle here, that back rectangle is a 5 times a 6. So let me just call that the back. So back is 5 times 6, which is 30 centimeters squared, and that's a rectangle. We don't need to divide it by 2. The next surface that I'm going to figure out the area of is maybe this right side here. That right side is a 6 times a 3, so I'm just going to call that the right. And the final surface that I'm going to find the area of, which I will highlight in pink, is this surface here, and this surface here is 4 times the height, which we actually see over here, which is times 6. So that left, maybe I'll call that the left. The left is 4 times 6, which is 24 centimeters squared. So at this point in time, we've calculated once again the 2 triangles and the 3 rectangles. And if we add all of those up, we get a total surface area of 84 centimeters squared.